Hello everyone. Myself Farhan Imtiaz Salwarkar, and I am here to present a PowerPoint presentation on the topic of combustion chambers and turbines. Let's understand how a combustion chamber works and what role it plays in a jet engine. So how does a gas turbine engine work? So a turbine engine operates on Brayton cycle. Brayton cycle is a continuous thermodynamic loop that converts fuel energy into thrust energy into sequential stages. So the stages are air intake, compression, combustion, and expansion. So while in the stage of air intake, the engine it takes the air inside through a propeller or a fan, which then that taken inlet air is then taken to compression stage, where the compression stage has compressors, and it is there are two types of compressors, that is high pressure compressor and low pressure compressor. And then that compressor compresses the air and it passes that air into the combustion chamber. There combustion chamber, it has the sole work of doing the propulsion. That is, it mixes the fuel with the air and it makes the air fuel ratio, and then that air fuel mixture it is combusted by the ignition, and then those expanded gases they pass through the turbine, and then the turbine, which is the expansion stage. The turbine has also two stages, that is high pressure turbine and low pressure turbine. So the high pressure turbine runs the high pressure compressor, and the low pressure turbine runs the low pressure compressor. And then the thrust that is produced due to the uh, ignition of the gases and the expansion of the hot gases, that thrust uh, helps the engine for propulsion. So, combustion chamber. A combustion chamber is, as I said, it is where the chemical energy converts to thermal energy. There in this combustion chamber, the fuel is mixed with air, and the air fuel ratio it is maintained, and the combustion chamber it has to be efficient. The fuel should burn completely, which will lead to maximum energy generation, and which will lead to maximum thrust produced, and also it has to minimize the emissions. That is, the fuel has to be completely burned so that it won't produce CO and other hydrocarbons, unburned hydrocarbons. Also, the temperature has to be controlled of the combustion chamber, because the gases, expanded gases, can exceed up to 2000 degrees Celsius. So the thermal management has to be precise. Then pressure maintenance is one key form. So the total pressure in the turbine has to be maintained, or which is very critical for preserving turbine engines. So there are various types of combustion chambers. First is can type, which is individual cylindrical chamber, and it is in earlier aircraft it was very common, the can type and combustion chamber. Then came annular combustion chamber, which is a continuous ring type of combustion chamber, which is surrounded around a turbine shaft. This was also this is also common in some aircraft nowadays. But the most used design nowadays is the cannular type of combustion chamber, which is a hybrid design with individual flame tubes. So it is like an hybrid of can type and annular type of combustion chamber, and it is now very efficient and the most used type of combustion chamber. So now let us see about turbines. So turbines are for extracting work from the engine. The main function of turbine is to extract kinetic and thermal energy from combustion gases and convert it for shaft work that drives the compressor. Or in engines like turboshaft or turboprop engine, it is used for turning the propeller. So there are two dominant designs, impulse turbine and reaction turbine. Impulse turbine is driven by gas momentum, which is simple geometry, effective for high rotational speeds. And another is reaction turbine, which is driven by both pressure drop and velocity change. It is highly efficient at lower speeds. So the challenges and innovations in this technology. So advanced cooling techniques, we have to implement very advanced cooling techniques. As I said earlier, that the overall temperature has to be maintained because the gases, the hot gases, its temperature can reach up to 2000 degrees Celsius. So we have to use materials that can sustain itself for longer period of time in such high temperature. Then additive manufacturing, we can use metal 3D printing that can enable us complex internal geometry, including cooling passages, and which can be possible with conventional casting, which is not possible for conventional casting, but we can achieve it through 3D printing. Then ceramic matrix, right now, as we see, composites are being highly developed and being used in aircraft industries. So we can use ceramic matrix as something that can help us in temperature sustainability. Thank you for joining my lecture, and thank you for being here.